Hello. Welcome back to Decaf-Math ASMR. And a warm welcome if you are new here. I hope that you are taking good care of yourself and that you're doing alright at this time. Today or tonight, whatever time it is for you as you're watching this, I wanted to just take some time and play around with some quadratic equations. This was a requested topic, but whether or not you're actually learning this stuff at the moment, I hope that you can find this relaxing. I hope that it is helpful if you're learning it, but feel free to just zone out, close your eyes, take a nice nap, or get some good sleep if needed. So, if you are learning this, I hope that the review or practice is helpful when it comes to math. Repetition can be really helpful. But if you're struggling with it, my goal for today's video is to just kind of break things down bit by bit to help you break it down to something that makes more sense, or to help you figure out where you're really getting stuck. Sometimes it's just a little knot, as I like to say, instead of it just being like, I don't understand any quadratics. Maybe you understand a certain scenario, but you forgot how to, move one thing to the other side or something like that. So my goal is to help you break it down, and then if you want to review another step further, let me know. That's what I'm here for. So let's take a look at quadratic equations in general, big picture ideas, and we'll just see what comes up. Alright, so first off, what is a quadratic equation? What are these kinds of problems? So the main thing is, let's say our main variable is x. You can substitute it with anything else, y, z, whatever else, right? But be sure that you're aware of what the variable is. So in this case, we'll write the general form with x. So this is the most general case. A, B, and C are numbers, okay? So anything you want. 5, pi, -2, 0. With one exception. A cannot be 0. And that's because that's the coefficient of the x squared term, okay? So x is our variable, we have a squared term. We have x here as a linear term, and then we just have our constant. But if a is 0, this whole thing goes to 0, and you just have a linear situation. The whole point of a quadratic is to have something squared, the x squared term. Not just something squared, but the variable part squared, okay? So a cannot be 0, because otherwise you just have like 2x minus 3 equals 0, linear. So with quadratics, we must have a variable squared, and then the rest of it can be whatever. This can be 0, this can be 0. So we'll talk about each situation, okay? And to be really strict about it, I guess this is only when you have one variable. So theoretically, when you're talking about degrees of 2, you can have multiple variables, blah blah blah. But we're talking about one variable, and that one variable having a squared. Okay, cool. So that's quadratic. So sort of a picture to associate it with it would be a parabola, right? A parabola, or yeah, I don't know where I was going with that. But a parabola and the quadratic equation. where I was going with that is when you have something like this, anything of this form, notice the 0 is on this side. If you have like a 2 on this side, you can always subtract 2 on both sides to force it to be 0 here. You would just change up your constant, right? So once you have it in this form, the one thing you can always try is the quadratic formula, okay? So the quadratic formula is x, which is the same x here and here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What does that mean? This is literally the solution or solutions, if there are any, what a mouthful, to this. So negative b, so you literally plug and chug these values. Take the middle one, negative that, plus or minus. So that means there's presumably two situations, plus this or minus this. The square root of that b squared minus 4 times this number times this number. That's what the 4ac means. And then all divided by 2 times that first number. So this is going to be a number. The plus or minus thing, like we said, is just negative b plus this stuff all over 2a, or x equals negative b minus this stuff all over 2a. Okay. So that is the formula to memorize. You can always just start by trying this. Now, even just looking at that, there may be special cases. For instance, if b squared minus 4ac just happens to be 0, the square root of 0 is 0, negative b plus 0 is negative b, and negative b minus 0 is also negative b. So there will only be one solution in that situation. Okay, so it doesn't really matter. It's almost like if you just plug and chugged and you realize that this thingy is 0, you'll see that there's one solution. So you don't have to like check it if you don't want to ahead of time. You just go ahead and try this out. This is the most general brute force way of solving this. Okay. You might also notice if we have b squared minus 4ac and we get a negative number, the square root of a negative number is not real. You'd get an imaginary part. So that would mean that we would have no real solutions. When in algebra, that's usually where we stop. We just say no real solutions. But if you've learned about imaginary numbers, you'll say, the solutions are imaginary. That's fine. So you kind of just start plugging into this, and then as long as you calculate this part all right, you will be able to determine if there is going to be a solution at all, what that will be, and there may be multiple. Okay, so this is the most general, biggest picture scenario. So just memorize this formula. If you want your pal Decaf here to repeat it many times until you fall asleep in a future video, you can even let me know. I might just do that for relaxation and ASMR anyway. But that's the idea. So just memorize this, and if you're doing this step but you're consistently getting something wrong, I would probably point you in the direction of order of operations. Remember to do the negative b, do your b squared first, do your 4 times a times c first, and these are just calculation things. Do your square root, do that whole top part, and then do your 2a and divide by that entire value. So if you're trying to plug that into a calculator, just be aware of what step, do this one at a time, and if things are still going wrong, then make sure you're memorizing the formula correctly, and and if you're still stuck, just let me know. No worries here. So that's the general case, okay? Alright, so once you've kind of memorized that and sometimes you'll learn this in a different order. So this is kind of like why it's a big picture zooming back in, because sometimes you'll learn the shortcuts first. So that's the like case though, just you can always try, it doesn't hurt. But there are certain scenarios with quadratics where, let's say, b equals 0 or c equals 0, and you can use factoring or other methods to kind of just save you time. Now, if this whole thing can be factored, we can look at what to do. We'll do that case here too. But know that you could always just go ahead and still use the quadratic formula. You will get the same answers at the end, assuming you do your calculations correctly. It's just that it's supposed to save time. That's it. So when in doubt, quadratic formula. If you have no idea what to do and you're just, in a hurry, just go ahead and do it. If you don't know how to factor, you can't remember anything, just plug and chug straight into that formula. But you'll notice like that formula is pretty complicated, right? It's kind of messy, and sometimes these other algebraic methods help. So let's look at the different scenarios, like if b is 0 or c equals 0. So let's say the most trivial one, I think, is if b equals 0 and c equals 0. Why not, right? We're keeping this super general. So if we have ax squared equals 0, where a is anything as long as it's not 0, let's just say 2. We don't want to keep too many variables or placeholders here, so let's just put in a 2. 2x squared equals 0, so we would just move the 2 over, dividing by 2 on both sides, right? So if you divide by 2 on both sides, 0 divided by 2 is 0. So x is just going to be 0. The only way for something squared to be 0 is 0. 0 squared is 0. Most trivial case, right? When literally this is 0 and this is 0. So your question's like 2x squared equals 0, or negative 5x squared equals 0, or pi x squared equals 0. The only solution to that is going to be x equals 0. Seems kind of trivial, but it's still important because that's still considered a quadratic. So let's represent. Okay, so now let's do a similar situation, but now where b is 0, but c is not necessarily 0, or just not 0. So this is going to be really similar. A is still not 0, so we'll have like x squared minus 4 equals 0. Okay, so c is our constant. We have no linear part, so we have no x's, but we have 2x squared minus 4 equals 0. Again, this is the algebra part of it. We want to just go ahead and isolate this x. So by algebra, I just mean like one variable, one equation. Let's scoot stuff around and try and isolate my x to get a value. Like that. So because there's no linear x term, I'm just going to go ahead and move this 4 over. You can think of that as switching from a minus 4 to a plus 4 onto this side, or you can think of it as adding 4 on both sides. So I still have 2x squared equals 4. Okay, so just because I'm here to point you in a direction, if you have no idea how I got to this, that's totally okay. That's a separate question though. It's one-step equations, or just taking a step, moving across an equal sign. So if you need to review that, feel free to check out the Algebra 2 playlist, or also let me know if you want to review it some more. But that is a separate thing from this altogether. Similarly, now we want to get the x on its own, so we have a 2 times, and since it was 2 times that stuff, we're going to divide by 2 on both sides to move this 2 over here. It's your choice how you like to think of it. I like to think of moving because it's faster, but either way you want to undo the times 2. So this goes away, you get x squared Now there's one thing we have to pay attention to, which is when we have something squared equals a positive 2. When we take the square root on both sides, we have to put in the positive and negative square root of 2. So if I were to do this, I have to put in a positive or negative so that x equals the plus or minus square root of 2. So both situations, you can do that, or you can write absolute value square root of 2 or negative square root of 2. And that's because when you square it, that negative part also goes positive. So it's this particular situation. By definition, the square root of 2 is strictly the positive square root of 2. So you have to also put in the negative if you want to keep track of that situation too. So this is our solution for this. We have two solutions, and so in this particular case, without the linear part in between, again, it's just the algebra scooting stuff over to solve for x. So if you're stuck on this kind of situation, then I would say review this stuff, moving stuff over, isolating it, and conceptually try to break it down like this. Okay, so these are still special cases of the big picture. Again, if you plugged into the quadratic formula, you just happen to have b is 0. So negative 0 is 0, plus or minus square root of b squared is 0. So you have negative 4 times 2 times negative 4. You'll still get square root of 2. It's just that this tends to be much faster. Okay, so that's another situation. Now let's do when b is not 0, because we covered all the situations where b is 0. If b is not 0, but c is 0. So we're just playing around with these situations. I'm just trying to cover all the different cases so that you can break down the general topic of quadratic equations in general to these different methods. So this would be if you have the x term, but now this thing isn't there. So let's just do something like this. 5x squared, so a is 5, b is negative 10. You have your x, and then there's no c. It's just 0. So in this case, you'll see we have an x here and an x here. But because there's no constant term, we can at least factor out an x. So we can actually do this by factoring. So we have x goes into x squared x times, x goes into this, but we notice that 5 goes into 5, 5 goes into 10, so I'm going to factor out a 5x. Leaving me with an x here, because 5x times another x is 5x to the 1 plus 1, which is 2, minus 2, because 5x times negative 2 is negative 10x equals 0. So I just went ahead and factored that. If you don't know how I got from here to here, we'll just need to review some factoring, but that's totally okay. Now, here's another big concept for these kinds of questions in general, which is if you have something times something equals 0, the only way for that to be true is for each part to equal 0. Like either this equals 0, or this equals 0, or both, right? But at least one. Why is that? Because if you don't have either part be 0, there's no way that the product equals 0. The only way for something times something equals 0 is for at least one of them to be 0, because 0 times 2 is 0, 0 times 5 is 0, but if you have 3 times 7, there's no way that's ever going to be 0. So you would say 5x equals 0, or x minus 2. Or you can even break it down further and say 5 is never 0, so that's fine. X equals 0 or x minus 2 equals 0. However you want to do that. And then from here you get or x equals 2 because you add 2 on both sides. Okay, so that's again solving. You break each part down into either part being 0. So you either get x equals 0 or x equals 2 or both. And that's true because if you plug back into here, you get 5 times 0 squared is 0 minus 0 is 0. Or in order of operations, 2 squared is 4 times 5 is 20 minus 10 times 2 is 20. 20 minus 20 is 0. So either or, that's it. That's great. Okay, so for the situations where you have the x squared part in an x term and no constant, you can just factor out at least an x and then do each part. Okay, that's all. And that only works for 0, so you can't do this for like 1 or 10. You can't just be like 1 has to be 2 and the other has to be 5, because what if it's 1 and 10 or 10 thirds times 3 or something like that. You have to only have a 0 on this side in order to do this 0 product thing. Okay, cool. Alrighty, and last but not least, what happens if none of them are 0? Again, this can be just done using our quadratic formula. If there's going to be one, we can always check with the quadratic formula. We can just generalize everything based on that. But if we're going to try and look for a shortcut, we're going to try and see if we can factor. So same thing with that last step, except now we're going to have to do the backwards foiling kind of factoring. So we're going to need to come up with something like that. So let's say we have like this. Okay, so A is 1, B is -1, C is -6. We can, like I said, use the quadratic formula. X equals -1, so 1 plus or minus square root of 1 minus or plus 24 over 2a, so 2. You'll get 2 solutions there. But if we recognize that we can factor this, we can just do it directly without the quadratic formula. If you remember how to do that here. Two numbers that multiply to give you -6. So they're going to have opposite signs. One's going to be a plus, one's going to be a minus. You want the outside plus the inside to give you a -x. So in this case, like so, because -3 times 2 is -6, your outside is 2x, minus 3x is -x. So this is this factored. If you're not comfortable going from here to here, then I would direct you to factoring. And we can do more of that as well. We've touched on it here already and played around with it. But I just, again, want to help you break down the bigger problem into an area that you may just need some more practice with. So this is a factoring situation, and again, this would be, if you have a 0, this is a product thing. Either this equals 0 or this equals 0. Or both, right? So x minus 3 equals 0, or x plus 2 equals 0. And again, our one-step situation, you move the -3 over, move the positive 2 over by subtracting 2 on both sides. So x equals 3 or x equals -2. Or both. Like that. And if you went ahead and did the quadratic formula with the -1 plus or minus square root of 1 minus 4ac over 2a, you'll get these two. Remember the plus or minus part. So you'll get 2 solutions if the discriminant, the b squared minus 4ac thing, is greater than 0. So this is like a thing to kind of keep in mind with if you can recognize the factoring, or if you're just kind of stuck you can try to do that because this is much faster and less messy. Factoring, of course, if you can just look at it, and especially if there's a 0 here, that's always the most straightforward thing to do. But when in doubt, like I said, just go ahead and start with a quadratic formula. If you think that the numbers look nice and pretty, then probably missed a factoring somewhere, but that's okay. So that's what I have to say about that. I think that's all of the situations. Like we said, you won't get a situation where he's not 0. So notice that all of them are based on just taking one step at a time, just generalizing. What if this goes away? What if this goes away? But at the end, it's all based on factoring of some sort. So this is FOIL factoring, like the backwards FOIL kind of factoring. The other one is just pulling out the largest common piece that goes into both of them. And the other two scenarios are moving things to the other side and isolating the x. Just don't forget that when you take the square root on both sides for like an x squared equals something, you have to do positive and negative square root. I think that should cover all the different scenarios, and let me know if you have a particular question that involves a quadratic. If you need more practice with the actual quadratic equation itself, take your time with the order of operations in that, I would say, for sure. But really it's just memorizing that formula and getting enough practice. You'll get the hang of, like, okay, make sure you know what b is. B might be 0, might be sneaky. Just remember, b is always the number in front of the x. And of course, if there's like a 5 here, like we said, move the 5 over. So why don't we just end on a random situation with the quadratic, where this is not 0, and we'll just sum it up there. So I have no idea if this is gonna work or not, but I'll just make up numbers. So how about just 2x squared plus 3x plus 4 equals 1? Because I'm original like that. 2, 3, 4, 5. Okay, so before we do anything, we have to get this side to be 0. So we're gonna move this 5 over here by subtracting 5. So 4 minus 5 is -1, like this. Okay, so we have a, b, c is the whole -1. So x equals -3, because that's the negative b, plus or minus the square root of b squared. So 9 minus parentheses 4 times 2 times -1. So 4 times 2 is 8 times -1 is -8. All over 2 times a, 2 times 4, or 2 times 2 is 4. So this kind of got cut off, but I think you can see it. It's just the square root of 17. So -3 plus or minus 9 minus 8 is 9 plus 8 is 17 all over 4. So it's -3 plus square root of 17 over 4 and -3 minus square root of 17 all over 4. And you can kind of approximate that on your calculator. So in this case, because that inner part is positive, we do have two solutions. So that would be an example of just applying the numbers there. If you have any other questions, let me know. Don't hesitate to let me know. This is specifically with quadratics, so that's the something squared situation. And that's only if it's all expanded like this. If you have something like, I don't know, where it's already factored for you, you can always just multiply it out and get it into this form. Otherwise, you might want to like mess around with it in the big picture. Like if you have, trying to cover all the bases here, if you have something like this, you can always expand this out using FOIL or memorizing the perfect square situation. But x squared minus 4x plus 4, multiply the 5 out, combine your constant terms to get it into this form, or you can directly solve by doing the thing of moving this here, so plus 10, then divide by the 5. Then remember, when you're square rooting on both sides of something squared, you have to do plus or minus the square root of that, and then move the 2 over. So something like this would be a, let's move everything and isolate x. So my biggest tip of all is to keep track of what your variable is. What are you trying to solve? If it shows up in multiple places, we might want to try factoring. We might want to try the quadratic formula. If it shows up once, then we might want to try isolating it using, the opposite of what's happening. So if it was subtract, you add. If it was multiply, you divide. If it was squared, you take the square root, keeping track of whether or not you need plus or minus square root, and just do that one step at a time. Okay, I hope that this was helpful, and might not be super sleepy, I'm not really sure. It wasn't super intentionally sleepy, but I hope that it was relaxing, that's for sure, and I will see you around for more math very, very soon. We can do specific practice of any of these forms, so let me know.